The upcoming launch of Tesla's new 4680 generation battery is generating great interest and expectations in the automotive industry. Planned for the Tesla Model Y Juniper in 2025, this technological advancement promises major innovations that deserve special attention. In addition to being an improvement over the cells previously used in the Model Y, the new 4680 batteries mark a major chemical development recently revealed that could revolutionize Tesla's approach to battery technology. These modifications, which are significantly different from previous generations, illustrate remarkable progress in the development of Tesla batteries. The cells for the Model Y Juniper represent a technological leap and include innovations that could transform not only the performance but also the energy efficiency of the brand's electric vehicles. For example, new batteries are expected to offer higher energy density, which could translate into improved range for drivers. This increase in energy density is essential to meet users' increasing demands for range and performance. As we delve into the new features, it becomes clear that these innovations will not only benefit the Model Y, but could also lay the groundwork for other future Tesla models. The introduction of 4680 technology could create interesting synergies within the company's product line and allow Tesla to offer even more competitive vehicles. By incorporating these improvements, Tesla is strategically positioning itself to maintain its leadership in the electric vehicle market. The new 4680 batteries also promise shorter charging times, a key factor in the mass adoption of electric vehicles. Drivers who are increasingly concerned with convenience will no doubt appreciate the ability to quickly charge their vehicles, which could help overcome one of the main barriers to electric vehicle adoption. The impact of these changes on the future of Tesla vehicles could be significant, making them even more competitive on a global scale. The ability to optimize both performance and production costs could allow Tesla to continue to innovate while meeting the growing demand for environmentally friendly vehicles. Therefore, it is important to take a closer look at what is new in the 4680 battery and its potential impact on the next generation of electric cars. To understand the improvements made, it is important to know the reasons that led Tesla to make these changes. First-generation batteries had significant limitations in terms of performance, charging time, and energy density. These shortcomings became apparent during testing and led Tesla to look for solutions to overcome these challenges. In addition, the company encountered obstacles in the manufacture of cathodes using the dry electrode coating (DBE) process. Although this method aims to reduce manufacturing costs and time, it also brought technical challenges that Tesla had to overcome. With the departure of the inventor of this process last year, the situation became more complex, creating uncertainty about the continuity of improvements. Yet despite these difficulties, Tesla has provided some encouraging updates in recent months. During a conference call on the first quarter results, Lars Moravy, Vice President of Vehicle Engineering, reported that production of the 4680 battery was higher than that of the Cybertruck. He specified that the production capacity would allow the assembly of more than 1,000 Cybertrucks per week, which represents a significant advance. This announcement underlines not only Tesla's determination to innovate, but also its commitment to overcome the challenges associated with the manufacture of next-generation batteries. In short, the launch of the 4680 batteries represents a critical milestone for Tesla and could well define the future of electric vehicles. The combination of new technologies, chemistry improvements, and an efficient production strategy positions Tesla to continue to dominate the market. As the company prepares to launch these innovations, the automotive industry's attention remains focused on the potential impact of these batteries on vehicle performance, user experience and, ultimately, the future of electric mobility. Nevertheless, Tesla still faces the critical challenge of resolving performance issues related to the 4680 battery. If these issues are not effectively addressed, mass production could result in the product not fully meeting consumer and customer expectations. This challenge should not be taken lightly, as battery performance is critical to the range and reliability of electric vehicles, which are essential criteria for conquering an increasingly competitive market. At a previous investor conference, Drew Baglino, a Tesla executive, announced that the company was ready to launch an improved version of the 4680 cells that offers 10% higher energy density compared to the first generation. This gain was achieved by optimizing manufacturing processes and cell design. Such an improvement is significant because it can directly impact the range of the vehicles, allowing drivers to travel longer distances on a single charge. Notably, Tesla's Texas office is preparing to launch these new cells for the Cybertruck that incorporate these promising improvements. A key discovery contributing to this increase in energy density is the development of a lower-profile battery cover design. This design expands the space available for the electrodes inside the cell, increasing the active surface area and optimizing chemical reactions within the battery. In addition, Tesla is also considering using thinner external cells, which could further improve the performance of its batteries by reducing internal resistance. The recent innovations in the second generation of 4680 batteries clearly illustrate Tesla's commitment to tackling engineering challenges and advancing its technologies toward more efficient battery solutions for its electric vehicles. James Ma and his team recently announced details of the notable changes to the cathode and anode chemistry of this new version of the 4680 battery. According to Ma, the new battery used in the Model Y will be manufactured at the Gigafactory in Austin, Texas, and uses NCMA-based chemistry, which contains 82% nickel, 11% cobalt, 5% manganese, and 3% aluminum. This innovative chemical composition is intended to maximize energy density while reducing reliance on less durable materials such as cobalt. Compared to the first generation, the proportion of nickel and aluminum has increased slightly, while the proportion of cobalt has been reduced. The anode, in turn, is still made of natural graphite, but is now doped with a small amount of silicon, following the first generation design. These adjustments are key to understanding how the second generation of the 4680 battery improves performance and efficiency compared to its predecessor. When testing the first generation, which featured NMC 811 cathode chemistry, 80% nickel, 10% manganese, and 10% cobalt, and a gravimetric energy density of 232.5 Wh/kg, no silicon was present in the anode. However, the analysis conducted by James Ma detected a small amount of silicon, about 4%, in the cells tested. This discovery is particularly interesting, especially considering that Drew Baglino, a Tesla executive, had mentioned that the cells intended for the Cybertruck would not contain silicon. The addition of silicon, even in small amounts, could significantly improve battery performance and increase its energy density and overall efficiency. These advances are crucial for Tesla to achieve its ambitious energy density goals with the cell planned for the Cybertruck. In addition to the NCMA chemistry, Tesla also plans to introduce a new cathode chemistry, NMC 955, which promises to further improve cell performance. This alternative chemistry aims to optimize sustainability and performance while maintaining competitive production costs, which could lead to more attractive prices for consumers. At the same time, the company is testing an innovative asymmetric lamination technique that involves making one side of the material thicker than the other. The goal of this method is to increase the capacity of the battery gel roll, allowing for a better fit to the 4680 cell format. This lamination process could provide additional efficiency and capacity gain, making the batteries not only more efficient but also more compact, which is essential for electric vehicles. Despite the challenges Tesla faces, the 4680 battery innovations are promising. With continuous efforts to improve cell chemistry, optimize design, and overcome production hurdles, Tesla is well positioned to bring battery technology to market that could change the electric vehicle landscape. The company's commitment to continuous innovation will be a key factor in maintaining its market-leading position and meeting growing consumer expectations for performance, range, and sustainability. These developments in the chemistry and design of Tesla's 4680 cells demonstrate the company's commitment to leading the way in batteries, always seeking higher performance and durability in its electric vehicles. With the implementation of these new technologies, we can expect an era of greater efficiency and performance for future Tesla models. These innovations are not limited to performance improvements, but also aim to transform the user experience by offering more reliable vehicles adapted to the needs of an increasingly technologically demanding clientele. It is also important to note that Tesla is actively researching the chemistry of the NMC 973, which could be released in late 2024. This new chemistry represents a significant advance in Tesla's pursuit of even higher energy density and longer battery life. With all the changes to the next-generation 4680 battery, significant performance improvements are expected for the Model Y and other future Tesla vehicles, helping to cement Tesla's position as an innovation pioneer in the electric car space. The decision to change battery chemistry proved to be both strategic and relevant. Increasing aluminum content in the cathode while reducing cobalt is a trend that many battery manufacturers around the world are pursuing. Although cobalt is valued for its battery life extending and safety-related properties, its high cost and ethical concerns in extracting it pose a significant problem. By switching to this new chemistry, Tesla could significantly reduce the production costs of its batteries, which could make its vehicles more affordable and accessible to a wider audience, a crucial aspect of increasing its market share. Incorporating manganese and aluminum into NCMA cathodes reduces dependence on cobalt while solving cost and durability issues without compromising battery performance. Aluminum in particular provides better structural stability of the cathode, which can increase safety and extend battery life. This approach is not only economically advantageous, but also meets growing consumer demand for more sustainable and environmentally friendly electric vehicles. The promising results of NCMA cathodes likely motivate Tesla to continue using them, as this chemistry effectively reduces the need for cobalt, a material that is both expensive and ethically problematic. In addition, switching to a more sustainable chemistry could strengthen Tesla's brand image as a leader in responsible innovation, thereby attracting customers who care about the environmental impact of their consumption choices. A key question is who will supply Tesla with these cathodes. It is likely that LG Chem could play a major role by supplying finished cathode rolls or even cathode powder. This assumption is based on the fact that LG Chem has been at the forefront of the development of NCMA chemistry and recently started construction of a large cathode plant in Clarksville, Tennessee. The focus of this $1.6 billion investment is the production of NCMA materials with an estimated annual production capacity of 60,000 tons. With this capacity, LG Chem is ideally positioned to meet Tesla's growing demand for these cathodes and strengthen its role as a key partner in the battery supply chain. A collaboration between Tesla and LG Chem could be a key factor in securing Tesla's leadership position in the electric vehicle market while addressing cost and sustainability challenges. LG Chem's new factory is designed to power approximately 600,000 electric vehicles per year, each with a range of more than 300 miles. This represents a major step forward in meeting the growing demand for long-range electric vehicles, which is a key purchasing criterion for today's consumers. By incorporating this production capacity into its strategy, Tesla could not only increase its delivery rate but also optimize the overall performance of its models, which is critical to maintaining its competitive advantage in the market. In summary, innovations in battery chemistry and strategic partnerships with suppliers like LG Chem are critical to Tesla's future. As the company continues to refine its battery technologies, it strengthens its position not only as a pioneer in the electric vehicle industry but also as a model for sustainability and responsible innovation. These efforts are expected to result in vehicles that are not only more powerful and efficient, but also more accessible, positioning Tesla as a key player in the future of electric mobility. In addition, recent information indicates that Tesla has entered into a major agreement with LG Energy, a subsidiary of LG Chem, to acquire a significant amount of electrodes. According to industry sources, Tesla's purchasing team recently ordered $6 trillion, approximately $4.5 billion, worth of electrodes. Negotiations are ongoing and the signing of a contract is expected to take place in the second half of the year. Delivery of the electrodes will begin next year and span a period of 6 to 7 years, demonstrating Tesla's long-term planning to support future growth. This negotiation coincides with Tesla's redesign launch cycle and is strategically part of the upcoming launch of the Model Y Juniper, a highly anticipated model that is expected to benefit from advanced battery technology. Tesla has ordered enough electrodes to equip between 1.3 and 1.4 million electric vehicles, which is around 70% of its total production last year. This amount of electrodes ordered is evidence of a strong partnership with LG Chem that aims to support mass production of electric vehicles in the coming years. This proactive approach to supply chain management shows that Tesla is anticipating increasing demand for its electric vehicles and ensuring the company has the necessary components to meet that demand. Typically, battery manufacturers combine anode and cathode materials with conductors and lithium to create electrodes, which are then assembled into battery cells for automakers. Tesla's latest order suggests that the company is sourcing components that are close to final assembly. Although the report does not specify whether these electrodes are cathodes, anodes, or both, it is safe to assume that Tesla is primarily focused on cathodes. This seems logical, as the company has already mastered anode production using the dry coating process, while cathode production has presented greater challenges. By securing a significant supply of cathodes, Tesla is underscoring the critical importance of these components to battery performance and cost. Cathodes play a key role in battery energy capacity and longevity, and optimizing them is essential to ensure Tesla vehicles remain competitive in the market. With technological advances in the battery sector and increased collaboration with LG Chem, Tesla is well positioned to continue to drive innovation and expand its electric vehicle offerings. This ensures not only efficient, but also economical and long-lasting batteries. Starting in August this year, LG Energy Solution will work with Tesla to significantly increase production of 4,680 batteries, which are a core component of the American manufacturer. According to CEO Kim Dong-un, mass production of these batteries is scheduled to begin at the Pune, Korea plant between August and September, marking a critical milestone for Tesla's battery supply. In addition, LG Energy Solution is exploring several options to expand production of 4,680 format cylindrical batteries at its plant in Nanning, China, underscoring a global move to meet growing demand for this technology. Meanwhile, LG Energy Solution plans to start producing lithium iron phosphate (LFP) batteries in the second half of 2025. Currently, these batteries are mainly produced by Chinese manufacturers and are gaining popularity due to their efficiency and reduced costs. LG's expansion of LFP production represents a significant diversification of its portfolio and aims to meet growing demand not only from Tesla but also from other automakers adopting the 4,680 cylinder format, such as BMW, GM, and Stellantis. A recent article by Chinese media outlet LEDPA highlighted Tesla's ambitious goal of reducing the cost of these 4,680 batteries to a level that would allow them to be produced more economically in-house than by sourcing from external suppliers. According to this report, Tesla has issued an ultimatum: if the company does not meet this cost-cutting target by the end of the year, it may consider abandoning the 4680 battery project, which would harm its electrification strategy. However, several engineers involved in the development of the 4680 battery expressed confidence that this goal will be achieved. To achieve this, they believe Tesla will have to forego investing in producing its own cathodes using the dry coating process and instead favor sourcing from external suppliers. This strategy could allow Tesla to focus on optimizing its manufacturing and innovation processes while benefiting from the expertise of established partners such as LG Chem for the production of critical components. If Tesla focuses its efforts on improving its production capacity and reducing costs, the 4,680 battery project has a high chance of achieving the goals set. These initiatives from both Tesla and LG Energy Solution point to a promising future for mass production of advanced batteries, with the potential to revolutionize the efficiency and cost of electric vehicles. The collaboration between these two industry giants represents an important step towards more sustainable and accessible transportation on a global scale. With its focus on optimizing its manufacturing processes, Tesla aims to increase its efficiency while reducing the costs associated with the production of its batteries. One of the key strategies is increasing automation of production lines, which helps reduce manufacturing times and improve precision. In addition, by integrating cutting-edge technologies such as artificial intelligence and advanced analytics, Tesla can monitor the performance of its equipment in real time, anticipate failures, and minimize downtime. In addition, Tesla is exploring innovations in the design of the 4,680 batteries themselves, including manufacturing techniques that simplify cell assembly and improve their energy density. For example, by adopting a cell-to-pack battery design that eliminates intermediate modules, Tesla can not only reduce the overall weight of the system but also maximize the use of space on board vehicles, thus contributing to better autonomy. The collaboration with LG Energy Solution is crucial in this quest for improvement. LG Chem, with its expertise in battery chemistry and advanced production capabilities, enables Tesla to access high-quality materials while benefiting from sufficient production scale to meet growing demand. The two companies' joint innovation in cathode and anode technologies is also promising, as it could lead to advances in battery performance while reducing their carbon footprint. By integrating LG Energy's best practices and technologies into its own processes, Tesla can not only strengthen its position in the electric vehicle market, but also positively impact the entire automotive industry. The synergy between the two companies could also pave the way for new energy solutions, such as energy storage for renewable infrastructure, making the entire energy system more resilient and sustainable. Large-scale production of advanced batteries like the 4680 could have a significant impact on the cost of electric vehicles. By reducing manufacturing costs, Tesla could offer electric vehicles at a more competitive price, expanding its target market and making electric mobility accessible to a wider audience. This is part of a broader trend to decarbonize the transportation sector, which aims to replace combustion engine vehicles with more environmentally friendly alternatives.